So let us slowly start our session. So welcome back, all of you. So we are going to continue our discussion with our programming concepts. So again, we'll be revising some fundamentals today, just like how we saw yesterday. We were working on a data set. We were trying to apply some small commands, and we were trying to extract information from our data. So today also, we are going to do the same thing. And also I'll be sharing these files with you so that you can also practice and you can also apply these concepts. So let us start our discussion with the basic fundamentals. So this is our R Studio, how it is going to look like. And you have 4 screens here. Screen number 1, screen number 2, screen number 3, screen number 4. So these are our 4 screens. Now, let us try to execute some basic commands, how to do your addition, subtraction, multiplication, division, exponential. So very straightforward for us. So whenever you are writing any programs, you should always remember that you should explain what is your code trying to tell us. That means whenever you're typing out a small command, make sure you type some comments which are going to help the user understand what is the operation, what is the calculation you're doing in your program. So you can write with hash and you can say basic arithmetic operations. So you can just type out like this. You can say hash and then arithmetic operations first. So whenever you use hash, it is very similar to you are writing a comment which is going to explain whatever you are trying to do. Okay. So now let us run this simple addition. 5 plus 15, press Control Enter. You are going to get the output. So 5 plus 15 is 21. So you can give any numbers like this. I can say 4 plus 5 is equal to 9. Then 10 plus 10, 20. So in this manner, you can write small calculations. Okay. Now, just like how you can add your numbers, you can also subtract your numbers. So I can say 11 minus 5. And I can press Control Enter 6. Similarly, I can say 12 minus 7. Again, it is giving me the answer of 5. Then 7 minus 3. It is 4 for us. 5 minus 7. Again, it's minus 2. So like this, you can also work in your R Studio Cloud. And you are going to get the same results. There is no difference. So whenever you want to run any programs, it is not necessary for you to execute the command line by line or step by step. What you can do, you can simply select multiple lines like this. And then you can press Control Enter. So all the lines, the entire program, you can execute in this manner by selecting multiple lines first. So you don't have to execute line by line to understand what is happening in the code first. Now similarly, multiplication first. So 3 into 7, again, press Control Enter. It is 21 first. And then 5 into 7, you have 35. So in this manner, you can do small multiplications, subtractions, additions, all these things you can. Later on, we'll try to see much more complicated things first. For now, let us go with the basics. Then 7 by 3 basic division operation. You can press again Control Enter. So it is going to give you 2.3. So this is what 2.3. And then similarly, you can take the exponential. So 2 power 4. If I want to find out, I can simply write it like this. 2 power 4 is equal to 60. So press Control Enter. Check the output. Output is fine. 2 power 4 is 16 for us. Then 5 power 25. So this is the value. 2.98 into 10 power 17. Then 5 square. So 25. So 5 power 2 is 25 for us. Then you can also write it like this. So this is very similar to 5 power 2. So this is also going to give you the same result, 25 for us. So small operations we are trying to do: addition, subtraction, multiplication, division, exponential, and modulus operation also you can do. So modulus operation. 8% percent 2. The modulus is going to retain the remainder first. 8 divided by 2. So you can press Control Enter here. Modulus operation. What is the remainder? 8 divided by 2. You are getting it as 0. Similarly, you can use ready-made functions like absolute function. Absolute of minus 25 is 25 first. Absolute of minus 25 is 25. Then absolute of minus 100. It is going to give you 100 first. Absolute of minus 100. So these are all built-in functions which are there. Square root function. Square root of 37. So 6 point something. So you can find out the square root of 37. 6.08. So you can just type out. Just type out any commands. Square root of 100. So you are going to get 10. So function is working for us. So you can apply all these functions and you can do some calculations first. So you can apply all these on your data set also. You can apply. Now we are saying square root of 36 whole square. So what is square root of 36 whole square? So I can write 36 whole power 1 by 2 whole square. So 36 is the answer first. you are getting 36. So code is working fine for us, and there are no difficulties. It is perfectly okay. Now, some basic arithmetic operations we have seen so far. Now, how do you assign values to variables? How do you assign values? You can either assign like this. We have already seen a is equal to 5, or you can assign a value like this. So any which way is correct for us. Either you can say equal to, or you can say less than and minus sign symbol. So what is the keyboard for getting this symbol? What is the keyboard shortcut? You can press Alt and minus sign from your keyboard. If you press this, you are going to get this symbol. This symbol you are going to get. So let us try that out. I can say, I just type out here A and Alt and minus sign, and I'm saying A is equal to 5. So automatically here on the right hand side, you will see the value of A has already been created. There is a variable A which has been created. A is equal to 5. Now, similarly, you can create any number of variables that you want. Similarly, you can create other variables also. So E is equal to 10. So like this also you can create, or you can create like this also. Any which way is fine for us. So E is equal to 10. So value of E is 10 for us. So if you want to print the output, there are two ways of printing the output. What is one way? You can simply say E like this and press Ctrl Enter. You will be able to see what is the value which is present in our variable. This value you will be able to know. Then if you want to see what is the value present in A, then you can simply say A and you can press Ctrl Enter. The value present in my variable A, it is 5 for us. So this is how you can assign values to our variables. C is 15. So I'm creating another variable called C as 15 for us. So now 3 variables you see, they have been created in alphabetical order for us, A, C, E. Now I'm creating another variable, B. I'm saying B value is 10. So now you see another variable called B has been created. So this is your environment where your variables are being created. Then D is equal to 25. So I'm creating another variable and D is equal to 25. So this is our D, 25. Now we have seen some examples. So far we have created some variables like this. Our variable name can be anything for us. You can have data.iris as your variable name. You can have lemon price as your variable name. So your variable name can be anything for us. Okay, it can be range value. This can be my variable name. So it depends on my convenience. Whatever I want, I can give as my variable name. So lemon underscore price, and I'm saying value is 2 for us. So this is the value 2 that we are having here. So this is a new variable what you have created, lemon underscore price. Then if you want to find out what is the value present in this way, then what is it you can do? Simply say lemon underscore price. So then you see it is going to display what is the value present in this variable for us. The value present in this variable is lemon underscore price, which is 2. Now, suppose if you give like this, what is going to happen? It is giving an error for us. So initially, when you're writing your programs, you're always going to get some errors. So our job is to fix these kind of errors. So always remember, how are you going to fix your errors? So simply copy this error, and if you paste it in Google, then it is going to take you to a place called as Stack Overflow. So this is a very famous website that you can use for fixing your errors. Any programming language, let it be R programming or Python, whatever programming language you are working with, this is the place where you are supposed to go. Stack Overflow. So there you are going to get all the solutions which are going to help you fix your errors. So that is what you have to remember as a developer or as a programmer first. So it is all about fixing our problems. So now it is giving us an error. It is called as lemon price not found. So that means it is not able to recognize this object because we have not created this object. It is nowhere here in our environment. So it is not able to understand what is this. So now you have to correctly mention that it is lemon underscore price. So now insert one underscore here, and then it is going to give you the value. So now it is able to recognize this object. So you can call these as variables, or you can call them as objects first. So any name you can give, either objects, or you can call them as variables first. So if you want to see the output of any object or variable, you simply give the name of that variable or object, lemon underscore price, or you can say print lemon underscore price. Anything print command we are seeing today for the first time. So you can say print lemon underscore price. The same output it is going to give you. It is going to give you the output of 2 first. There is no change. Similarly, if you give print A, what is the value you are going to get? It is going to give you this value, 5. So you are going to get print A if you give A is equal to 5. So this value we are going to get. So we can say print A. So this is the value. Now you can do some small calculations like 5 into lemon underscore price. So what is lemon underscore price value? It is 2. So 5 into lemon underscore price is nothing but 5 into 2 for us. This is equal to 10. So the answer what you are going to get for this command is 10 for us. So let us try it out. 5 into lemon underscore price. So this is the answer what you're getting. And now you can update the value for your lemon price. You are saying now the value, because of inflation, it could have gone up from 2. Your lemon price has gone up to 10. So now you see the price has been updated. Price has been updated. The lemon underscore price equals to 10 for us. So this is the updation what we are doing. Now, if you print your lemon price, what is the output you are going to see now? It is going to be 10 for us. This is the output of our lemon underscore price. Is going to be 10. So you can try this out. You can say lemon underscore price, and this is the value what we are. And then now if you say 5 into lemon underscore price. So now my lemon underscore price is 10 for us. So 5 into lemon underscore price is going to become 5 into 10. So this is 50 for us. So 5 into lemon underscore price is 50. So this is how you can simply work out some examples, create your variables, objects, store some values, do some calculations, and get your results. Now, a similar example you can do. Suppose you want to create one rectangle. So you are saying height is equal to 10. Height is equal to 10. Now, for creating a rectangle, first we have to understand that you need height, we need width, and then we have to find out area. So these things we have to define first. So let us try to define one by one. What is the height of your rectangle? Height is equal to 10. Define what is your width of your rectangle. It is 5. Define what is the area. Area is equal to height into width. Now I can say print area. So I can write like this. So I'm defining first my height, then I'm defining my width, then I'm defining a new variable called area, which is equal to height into width, and then print area I'm saying. So you can define all these variables one by one or in single shot. In one shot, you can select all these lines and you can execute the command. But as we are learning, always it is better to execute these commands line by line, step by step. So height is equal to 10 for us. The value of height is 10. So this variable or this object we have created, height is equal to 10. And then width is equal to 5. So this is another dimension of my rectangle, what I'll be creating. So width is equal to 5. Press Control Enter now. So as long as you are getting the results in blue color, we are perfectly fine. There is no error. So whenever you get message in red, so sometimes it could be error, sometimes it could be warning messages for us. So if it is warning message, we don't have to worry. But if it is error, we'll have to try and fix that error. So it is our job to fix these kind of errors whenever you are working on your programs. So now two variables we have created, height and width. So we are ready to create our area, which is a combination of height and width. Height into width first. So create area. So now your area has also been created first. So area is nothing but height into width. What is our width? Our width is 5. 10 into 5 is 50. So there has been a variable which has been created by us called as area, and the value present in that variable is 50. So this is the new object what we have created. It is called as area is equal to 50 first. So now you can simply say print area. So area value is 50. So we have created a rectangle with area 50 first. So now all these commands, what I have executed line by line, I can also select all the lines at once and I can press Ctrl Enter. So all these commands will be executed at once. In one single shot, you can execute all these commands. What is the advantage? Suppose if you are writing small programs. So individually, you don't want to run every single line of code. You want to select all the lines of your code together and you want to run the command. So it is going to save some time for us. So it is also possible. So select all these commands and you can click on run here. You see, run option is there. That option is going to give you your output. Or what is the keyboard shortcut for executing the command? You have to press Control and Enter. That is the keyboard shortcut first to execute your commands. Now, there is one new function what we are going to experiment with. It is called as ls function. So what is the ls function going to do? It can be used to see all the list of objects what we have created. So we can see all the list of objects what we have created with the help of this ls function. So these are all the objects what we have created. So ls is going to display all the objects that we have created. A, area, B, C, D, E, height, lemon price, MBA. So these are all the things, all the objects, all the variables that we have created. Now, there is another function called as RM function. What is RM function? Full form? Remove. So what is that I'm saying? I'm saying RM and in brackets I'm giving height, comma, width. So this is going to remove our objects or variables that we have created. It is going to remove your height variable. It is going to remove your weight variable. And then you will not be able to see those variables in your environment. So height and width will be disappearing from this place. So let us try to apply RM height comma width. Press Ctrl Enter here. So now you see these variables have disappeared. You cannot see them here. So height and width are gone. They are no longer there in our environment. So now how do you confirm that? How do you cross check your answer? give ls. So now when you give ls, previously you had height and width here, but now you are no longer able to see. So you have removed them from your environment. You have removed them from your workspace. Now, what more you can do? You can simply try and find out if you can calculate your area. So you are defining area as height into width. But now what is the challenge you are going to face is you no longer have height variable in our workspace. You no longer have weight variable in your workspace. So height is no longer available for us. Weight is no longer available for us. So then we are not in a position now to calculate area because you are going to get error. What is the error you are going to get? Object height not found. This is the error what you are going to get because it is not in a position now to recognize this variable height. It is not there here. So it is going to first give you an error because there is no such variable as height. So R is not able to understand. So if you press Control Enter here, you are going to get an error called as object height not found. It is not able to recognize. So like this, you can try and remove some variables from your environment and you can try and check if you are able to perform the same calculations or not. So RM function you have seen, RM is nothing but removing your variables or objects. You can also remove your data sets also. So yesterday, if you have seen, we have uploaded one data set for us. What is the data set? MBA data set we have uploaded. I'll show you one thing. MBA.csv. So we have uploaded this data set for us. Now, if you want to remove this data set from here, from your environment, what is that you're going to do? Simply, you are going to say RM MB. Now you see, your MBA data set is also gone. It is not available. So like this, you can remove your variables, your objects, your data sets, whatever you have created in your environment. It is possible for you to remove those things. If they are not required, if you are not using these variables, then you are free to remove them from your environment. So that is the idea. What is another way of removing all the variables or objects that you have created? Instead of using the remove function, there is a broom here. So when you click on this broomstick here, what will happen? It will erase. It will remove all these variables what you have created. So either you can use this complete cleaning of your workspace, it is going to do, or you can use your RM function. Anything is fine for us. So this is what we have seen so far. So we have seen assigning values to small variables. We have seen how to create your variables and objects. And then ls function you have seen, RM function, we have seen application. And we have also managed to create some errors and fix those errors. Understand and fix those errors. We are able to do this. Now, let us try to understand some basic concepts related to our data types first. So now data types are a numeric, character, and logical. So numeric data type means basically numbers in simple language. Numeric data type is type of data which is having numbers. Character data type is nothing but which is having characters, which is having characters for us. That means text data. Simple terms, you can call this as text data for us. Logical data type, that means data which is having true and false values. This is called as logical data type. So let us see one by one. What are the different data types available for us? So first, I'm creating one variable called as my underscore age. My underscore age is 20. So then create this. So now there is a variable what we have created. My underscore age is equal to 20. So this is a new variable. Now if you want to check what is the data type of this variable my underscore age, what we have created, you can simply use a function called as class and you can give my underscore age. What is the class of this variable or object my underscore age, you can give. So give class function and you can say control enter. So what is the answer it is telling us? It is belonging to numeric data type for us. So this is a number. So these data types are important because you can understand from this data type how much information you can extract from your data. So you can study what are the different functions you can apply on this data type, and then using those functions, how much information you can get. How much information we can get. That we can understand from this data type. So data types, you can also call it as flavors of data. Data can come in different flavors. It can come in numbers for us. It can come in text data for us. It can come in true or false, or logical. So that is what we are trying to understand. Different flavors of data. So now you observe what we are going to do. So we are trying to use one function called as convert a numeric data into character. So what we are supposed to use? As dot character. And then in brackets my underscore age. So convert that and store it in a new variable called my underscore age one. This is what I'm saying. Convert my data type and then store it in a variable called as my underscore age one. So let us try to execute this. So now if you see, my underscore age 1 is a new variable which has been created, and it is having the value of 20. But this data type is character data. How do I know it is character data type? Because this value is present in quotation marks. So whenever the value is present in quotation marks, you can understand it is text data or it is character data. This is what we have to understand. It is text data or character data. So now how do you confirm? One way of confirmation is by looking at the environment. What is the value? Another way of confirming is simply I'm going to apply my class function again. Now I'm going to say class and I'm going to say my underscore age 1. Then it should give me the output as character. Then I can understand that it is character data type. So apply your class function on my underscore age 1, press Control Enter. So now clearly you can understand that it is belonging to character data type. So this is how you have to always cross-check your answer. You have to cross-verify, you have to try out multiple examples, and then you have to come to a conclusion. That is how it is going to help us in our analysis. Now, if you look at the next step here, so you are using another function called as .numeric. Now, what is this function going to do? It is going to convert your data type to numeric. So suppose if you want to convert my underscore age 1 into numeric, then you have to say as.numeric. Apply this function my underscore age 1. So apply this function as.numeric on this variable my underscore age 1 and convert this data into numbers. And then I'm saying store that in a variable called my underscore age 1. So this value you are converting back into numbers. So how are you converting back? You are saying as.numeric and in brackets my underscore age 1, and then you are storing the results again in a variable called my underscore age 1. This is what you are saying. So press Control Enter. So now you see on the right hand side, we are able to see that this variable now, my underscore age 1, is of numeric data type for us. How can we confirm? Because there are no quotation marks. There are no quotation marks. So therefore, it is belonging to numbers, numeric data for us. How can you double check your answer? You can double check your answer by giving this class function, my underscore age 1. So we give your class function, class my underscore age 1. Then you can clearly understand that it is numeric for us. So this is how you can confirm that my underscore age 1 variable is a numeric data type variable for us. My underscore age 1 is a numeric data type variable for us. Now, just like you have created your numeric data, you can also create your character data. So now how can you create your character data? Simply create one variable, my underscore name, and then you can say my underscore name is equal to some name you can give XYZ, or my underscore name, I can give it as Thomas. So now it can understand that this value of Thomas is getting stored in this variable, my underscore name. My underscore name is having character value in that variable. That is a character data for my underscore name. So here we are saying Nicholas. My underscore name is equal to Nicholas. This is the character data, what we have created. My underscore name, Nicholas. So how do you know it is of character data for us? Because it is, the value is having quotation marks for us. So my underscore name data belongs to character data type. It is having character values. Now, how can you double check your answer again? If you give class my underscore name, and then it is going to give you an output as character data type for us. It is going to give you as character data type. Now, how can you create here logical data? So logical data type, I'm just giving one variable is underscore data scientist. Any variable you can is underscore data. So this is a variable what I want to create. So now I'm storing a value of 2. Let us create this variable is underscore data. So automatically whatever variables you are creating, you should be able to see in your environment. So is underscore data is having a value of 2. So now if you apply class is underscore data, then it should give you the answer of logical data. So let us try this out. Is underscore data. Let's control enter. So it is logical for us. So we are able to get this answer. Logical. So now I can try another example. I can create another logical data. A is equal to true, I'm saying. And then I can give class of A. A is equal to true. And then I can say class of A. So again, you are going to get the answer. So you have value of true, which is stored in your variable or object A, what we have created. And then if you say class of A, it is going to give you the answer of logical. That is what you are able to see, logical. So that is how you can create your numeric data. You can create your character data. Okay, you can create your logical data also. You can create in this map. So all these things you can create. Now, so we have seen these things. We have seen class function. And just like class function, you can also use another function which is called as is.numeric. So is.numeric function is going to tell you the same thing. So I'm saying is.numeric, check my underscore age 1. So is it a number or not? You want to check this. So what is the answer it is going to give us? It is going to give us true. So my underscore age 1, it is a number first. My underscore age 1 is a number. So same result you are getting. It is a number. It is true. And then if you see is.character, now you want to check whether this my underscore name is of character data or not. So just like class function, you also have another function called as is.character my underscore age. Or let us try with my underscore name. You can try with any variable. So let us try both of them. My underscore name and my underscore age 1 also will try. So is.character my underscore name. So it is giving true. So this is character data only. This is character data. And then let us try it on my underscore age 1. So if you try is.character function on my underscore age 1, it is going to give you answer as false. What is the reason? You are going to get the answer as false because my underscore age 1 is numeric data. It is not character data. So that is the difference. It is not numeric data. It is numeric data, but it is not character data. So is.character on my underscore age 1. The output what you are going to get is false. So this is what we have to understand. So either you can use your class function or you can use your is.numeric, is.character, is.logical also. So let us try to explore that. Is.logical function. So you can type is.logical. Is.logical. Okay, then you can say my underscore age 1. Press Control Enter, which will give you false. So it is not a logical data. So let's try with is underscore data. Is.logical function. Is underscore data for us. Now it is telling us is underscore data variable or object is actually a logical data for us because it is having the value true. So is.logical function also you can use. Is.logical. So whenever you want to know how any function is going to work, so what is that you can do? Simply you can press question mark and you can say is.logical. Press Control Enter. So it is going to give you information, true and false. So is.logical you can use, as.logical you can use, and it is going to give you some examples. So all the information which is required, you can simply get with the help of your question mark and the name of the function. Just like is.logical, you can use is dot character. So it is going to talk about your character data type. Then you can give is dot numeric. So that also it is going to talk about your numeric data type. So vectors and all we are going to see in few minutes. The vectors is nothing but it is a simple list of numbers. It is list of values for us. That is a vector. So we are going to discuss some examples going forward. So what is that we have to understand here is whenever you are in doubt of how to use any function, so you can simply give question mark and you give the name of the function. Is that logical? Is that character? Is that numeric? So this is what you are supposed to use. So that is the idea. So far we have discussed some basic functions, ls, okay, rm functions, some other arithmetic operations such as exponentials we have seen, and also square root functions, absolute functions like this. And then we have seen class, is dot numeric, is dot logical, as dot numeric, as dot character, as dot logical. So all these functions we have seen. So you can apply them on your data set. Straight away you can apply and you can find out what is the data type for each and every variable. So it is a good exercise for us. So on your data sets also you can find out. So yesterday we have seen structure of MBA we said. Then all the variables what we had, data serial number, it showed us numeric data type. Then you had GMAT column. This also it showed us numeric data type. It had work experience column. It also it showed us the numeric data type. They are all numbers. All these columns are having numbers. So what is the logic? Straight away import your data set. And then you can apply your structure function. So our data set has been imported. And then you can try out structure MB. So it is going to give you what is the data types. Okay, all are integer values for us. So this is how you have to extend your concepts what we have discussed, and we should be in a position to apply these concepts. So more and more you can take a look at these functions. You can apply them on your data, or what you can do is you can apply them on your data sets. Either you can import from outside, or you can also use the ready-made data sets present inside our R. So anything you can do. So now the next topic what we are going to discuss is vectors. So before that, let us take a break here for 10 minutes. And then we are going to come back after the break and we're going to talk about your vectors. Numeric vectors, character vectors, logical vectors we'll try to understand, and we'll try to do some calculations. So take a break for 10 minutes. So let us continue our discussion. So vector is a combination of multiple values. So you can have numeric vectors, you can have character vectors, logical vectors. In this manner, you can have. So let us try to understand one simple numeric vector. So it is a list of numbers for us. So this is called as a numeric vector. Now, how do I create a list of numbers in R? You have to simply say C, and in brackets you have to give what are the values that you want to consider. So C is nothing but it is a generic function in R. It is going to combine all the elements and it is going to create a vector or a list of values. So that is what it is going to do. So now here we are trying to create one numeric vector, friend underscore ages. And in this, we are trying to combine our values. We are trying to create a list of values first. What are those values? 27, 25, 29, 26. So press Control Enter. So now you see this is a numeric vector what you have created. So these are the four values that you have: 27, 25, 29, and 26 for us. This is a numeric vector. Now, before we go any further, let us try to explore this generic function called as C. So C function, it is going to combine the values into a vector or a list. It is going to combine all its arguments into a list or vector. So that is what is the purpose of your C function. So far, we have been just able to explore any function in R by giving question mark. You can also go to your internet and you can simply type there C function in R. Then it is going to take you to the same R documentation page. And it is going to give you the same result. So how to do that? You can go here and you can say C function in R, and then if you scroll down, R document. If you see, it is going to take us to our R document. So it is the same explanation. What you are seeing there in your R Studio, that same explanation also you can go to the internet and you can get that same information. So anything up to your choice. Either you can use your question mark and you can try to find out what is the purpose of that function, or you can simply go to the internet and type what is the use of that function. So C is used for combining values into a vector or a list. So that is the purpose. Combining values into a vector or a list. Now, if you say friend underscore ages, now, if you press Control Enter, so these are all the values what you are getting. So 27, 25, 29, 26. These are all the values what we are getting. Now, this is the information which is required for us to understand about the concept of numeric. So similarly, how do I create my character? So very straightforward for us. Again, you can give it some name, my_friends, and you can just give some random names. I can say Thomas, Jacob, and then Jim. So these are my_friends, Nicholas, Thomas, Jacob, and Jim. So I can simply press Control and Enter. So now we have created one character vector with our friends, Nicholas, Thomas. So if you hover your mouse, you see, you are able to see all your friends' names, Nicholas, Thomas, Jacob, and Jimmy. So this is how you can create your character vectors. So now if you say print my_friends, it is going to display the name of your Nicholas, Thomas, Jacob, and Jimmy. Now you want to create your logical vector. So I'm creating a simple logical vector in this manner. What is the name of my logical vector? R_married. And I'm storing these values: true, false, false. So this is a logical vector what I'm doing. So now if you scroll down, you see it is showing R_married is a logical vector what you have created. Why it is logical vector? Because you are having logical values: true, false, false, and true. These are the values what you are having. So this is a logical vector what you have created. Now observe what we are going to do. Thomas, Jacob, and then Jimmy. So now we want to assign our names. So we want to assign names to our logical vector. So we want to assign names here. So how do we assign names? Simply in R, there is a ready-made function for us. A ready-made function is there, and you can call it as names. There is a ready-made function for us. So if I say names of this logical vector R, what are the names? Nicholas, Thomas, Jacob, and Jim. These should be the names first. So press Control Enter. And now you try to check what is the output. So you see, your names have been assigned. So name for true has been assigned as Nicholas. Name for false has been assigned as Thomas. Name for false has been assigned as Jacob. Name for true has been assigned as Jimmy first. So this is one way of assigning our names. Now later on I'll show you what is another simpler method of assigning your names. If this is confusing for us, then there is also a simpler method that also we are going to discuss. And now if you observe, I'm using one simple function called as column bind function, cbind function. Now what is this column bind function? It is going to combine your data into columns first. It is going to combine our data into columns. So what is the data you want to combine? You want to combine two vectors. R underscore married is one vector, and you want to combine my underscore friends. This is another vector. So first, let us try to combine. Then I'll explain you what is happening. So my underscore data one. So we have combined. So what is happening? You see R underscore married and my underscore friends, they have been combined together in the form of columns. So you have true, false, false, true. You have Nicholas, Thomas, Jacob, and Jim. You have these names first. But you also have row names. So these are called as row names first. So now if I don't want to see these row names, so what I can do, I can say row names of this data, my underscore data one is equal to null. Then what is that I'm saying? I'm saying make the row names of my underscore data one as null. So don't show me these row names. That is what I'm saying. So apply this. Now, what is my underscore data one? So my underscore data one is simply not having any row names. So we have converted our row names into null, and now we are not able to see any of your row names. So now if you say of my underscore data one, what is the dimension of your data? It is having 4 rows. It is having 4 rows. 1, 2, 3, 4, and it is having 2 columns. So 4 rows and 2 columns it is having. So 4 cross 2 is the dimension of our data. So 4 cross 2 is the dimension of your data. 4 rows and 2 columns. You can apply this on your data set also. So these functions can be applied on our data set also. So we have our MBA data set here. So now if I say dim MBA, so you see it is going to show us what are the dimensions. You have 773 observations or rows, and then you have 3 columns. So this is the information what you are getting. So dimensions can be applied. This function can be applied on any of your rows. That is the logic. So now so what is it we are trying to do here? We are again trying to assign our names. But this time we want to assign our names to our numeric vector. What we have created. We want to assign our names. So what is it we are trying to say? Names of my friend underscore ages are Nicholas, Thomas, Jacob, and Jim. So press Control Enter. And now try to see what is the output that you are going to get. So you see now your names have been assigned to all your numeric vector values. So there is a ready-made function for us called as names. This is one method I told you. What is the second method? Second method is very straightforward. You don't have to use any names function. And so what is that simply you can do? You can simply assign values like this. You can say Nicholas is equal to 27. You can say Thomas is equal to 25 years of age. You can say Jacob is equal to 29. You can say Jimmy is equal to 26. So this is what you can say. So this is how you are going to assign. So instead of using my names function, I can simply say Nicholas is 27 years old, Thomas is 25 years old, Jacob is 29 years old, and Jimmy is 26 years old. So this is what I can say. This is another way of doing it. Same thing what you. So if you say friend underscore ages, it is giving us the same result. Nicholas is 27, Thomas is 25, Jacob is 29, Jimmy is 26. This result you are able to get. So there is no difference. Any which way is fine for us, as long as you are able to meet your requirements. There is no such difference between the two methods. So in the same manner, if you want to assign some values to your logical vector, previously you said names. You said names of R underscore married, and you gave all these names. But now instead of doing that, I'm simply saying Nicholas is equal to true, and then Thomas is equal to false, and then Jacob is equal to true, and then Jimmy is equal to true. So this is what I'm saying. Same thing, same output you are going to get, but only it is simply two different ways of giving the same result. And then you can check the output. Class, you can use your class function, and you can say, you can find out what is this vector. So for now, before doing this step, I'm going to show you the output. I'm going to show you this output. Friend underscore ages. They are getting the same output. So for true, you have assigned the name Nicholas. For false, you have assigned the name Thomas. For true, again Jacob. For true, Jimmy. So this is what you have. Now, if you want to find out what is this, what type of data you are working with, you can clearly understand that it is a logical data. The data what you are working with is logical data, because the values what you have for your names is true, false, true, true. So it is a logical vector. So that is how you are supposed to develop these kind of vectors. So save your work, whatever you are doing. Always it is better to save our work. You can click on this option. It is going to get saved. And then we can understand how to create these vectors. So numeric vector, character vector, and logical vector. So this is what we have been seeing so far. So now the time of the day is 8:30. So I request all of you to first fill in your attendance form, which will be circulated for you. So try to fill in with all your details in the attendance form, and then you can always come back and you can again listen to our. So first try to do that. Try to fill in your attendance sheet. I'll give you 2 minutes time, and then we can come back and start our discussion. So fill in your attendance form. So yeah. So just 1 second. I'll try to see if the attendance sheet is circulated or not. Yeah. So attendance link has been circulated to you. You can find it in your chat window. So that is the first job what you're supposed to do. Try to fill in all the information in the attendance sheet, and then you can always come back and we can discuss. So please try to circulate the attendance link again so that all the students are able to fill those details. So please try to do that. Yeah, thank you very much. So let us continue our discussion. And now you see what I'm going to do is now to the same numeric vector what we have created, I'm going to append one name, and along with that name I'm giving what is the age of this person. So this name I'm appending here. So press Ctrl Enter. Now we have created one numeric vector by the name friend underscore ages. So if you see, this is a numeric vector what we have created. So you have all the names: Nicholas, Thomas, Jacob, Jimmy, and Varun. All these names you have. Now there is a new function what I'm going to use. What is that function called as? Append function I'm going to use. Append function. So append my numeric vector. What is my numeric vector? My underscore friends. So scroll down here. Where is my underscore friends? This is. So I'm saying append my underscore friends. Okay, this is a character vector what we are going to use here. So I'm saying append my underscore friends, and I want to append this name after position number 1. So let us see what is first. My underscore friends, it is a character vector. It is having all these values: Nicholas, Thomas, Jacob, and Jimmy. And now I want to append this person's name Varun after position 1. So append it. So now you see, after position number 1, it has appended the name called as Varun first. So now if I want to append this person's name in the first position, then what I'm going to do? I'm going to say after 0. So now you see, this person's name Varun is in the first position now. 1, 2, 3, 4, 5. Remember, in R, the indexing is going to start from always position number 1. So indexing is going to start from position number 1. Either it is row or column. Remember this. Indexing is always going to start from position number 1. So now, this is how you can use your append function. So now, instead of my underscore friends, if I say friend underscore each, so now you see, it has appended. It has appended our name after 0th position, first position. It has appended. That is the logic. That is how you can append your names. So that is how you are supposed to use these kind of functions. Now let us go back and make it my underscore friends. So now it is fine. So far we have been discussing some functions like ls function, rm function. Then you have used is.numeric, is.character, is.logical. All these functions you have used for checking the data types. Class functions you have seen. And then as.numeric, as.character, then as.logical. For converting your data types, you have used these functions. And then you have seen now append function, you have seen names function, you have seen column bind function. Okay, binding them together in the form of columns. And then you have seen row names function. So all these functions are going to help us in doing the preliminary data analysis. All these functions are going to help us. Now, what is the next function you are going to see? Length function. So if you say length of my underscore friends 1, so it is going to tell you how many objects are there in this character vector what you have created. How many observations are there? 5 observations. What are they? Varun, Nicholas, Thomas, Jacob, and Jimmy. So you have 5 observations first. So this is what we have to understand. 5 observations are. So length function is another function what you can use. Now, suppose if you have missing values. So yesterday you have seen a data set was having a missing values. So now let us try to create some data with missing values first. So now I'm creating one new character vector. What is that vector name? Have underscore child is the new character vector what I'm creating. And I'm storing some values. Nicholas is yes, he is having a child. Thomas is having a child. Jacob is not having. Jacob, we don't know. Jimmy also, we don't know. This information is not there. For some of your friends, you are having information. Nicholas is having a child. Thomas is also having a child. But Jacob and Jimmy, they are not given us any information. We don't have any information about it. So this is a vector what you have created, have underscore child. And it is a character vector what we have created, have underscore child, because it is having these values, yes, yes. Now, I'm going to teach you one new function. what is that new function going to be? Is.na. So is.na is nothing but it is going to check whether your data is having your null values, whether your data is having null values. So let us check for that. So yes, you can understand from here that Jacob and Jimmy, they are having null values first. So Jacob and Jimmy are having null values, whereas Nicholas and Thomas, they are not having null values. So this is a useful function for us, is.na. So whenever you are in doubt, apply missing values function, is.na x. So you can scroll down and you can read through some of the documentation. So you can take some examples from here. Always, if you want to practice, use ready-made examples which are there in R files. So is.na and you are using two values. So what is the answer it is telling us? It is telling us that here there is no null value, here there is a null value. So try to apply these kind of simple functions, what you can use. Okay, simple functions are going to give you a lot of understanding. Now, so what I can do now, if I want to slightly modify my data, I'm going to write one small function. What is that function is? If there is a null value in my character vector, find out what is that observation which is having null value. Suppose Jacob is having a null value. Then replace this null value with no. So what is that I'm doing? I'm replacing my null values with no. So this is called as imputation for us. So you are imputing your missing values. So I am replacing my null value with no. So you are able to modify your data set by replacing your null values with a value called as no first. So this is an important technique for us. Your data set is going to have null values first. So you can replace those null values. You can modify those null values with some other alternate value, which is going to help us in our analysis. Which is going to help us in our analysis. So that is very important for us. So replacing your null values. So we have replaced Jacob and Jimmy. We have replaced it with some null value, with no value for us. So now you have filled in all the values for your data set. And now your data set is complete for us. It is not going to cause any problems. So this is one way of doing it. You are replacing the value. Another way is you can remove your null values. You can also remove your null values in your data. That is another form of imputation. That is another method of handling your null values. Either you can remove your observations which are having null values, or you can replace those observations with all our alternate modified values. This is called as imputation. So remember these concepts, whatever we have discussed so far in our today's session. So now let us try to revise whatever topics we have discussed today. So we have started off with basic arithmetic operations for us. Okay, we started off with this. And before that, let me just save this file for you. Okay. And save this file, basic R scripts, practice. This file I've saved. Now you see the file name has changed. Now what I'm going to do is I can share this file with you. Okay. So try to take this file from your Zoom chat window. And you can also practice whatever things I've done. So I've shared the file with you in your Zoom chat window. So you can take it from there and you can practice at your convenient time during the day, and you can understand, you can apply the concepts, what we have discussed. Okay, so that is the best part. Do that. So now, in our today's discussion, we have practiced our addition operations, subtraction operations, multiplication operations, division operations, all these things we have. Exponential operations, then a modulus operation, square root functions we have seen, absolute functions we have seen. Okay, all these functions we have seen. And then we have learned about how to create our variables, how to create our objects. We have discussed a is equal to 5, or you can use this symbol. This is your assignment operator, and you can assign a value to your variable. And you can create as many variables as you want, as many objects as you want, and you can do some small calculations using those variables. And then there are two ways of always getting your output. What are the two ways? I can use that. Either you can mention the name of your variable or object, like A, B, C, whatever you have created, you can mention this. Or what you can do is, you can also say print A, you can say print B, you can say print C, print D, like this you can say. So this is also going to give you your output. And then how to create your rectangle we have seen, assigning the value for height, assigning the value for width, and finding out the area, and then calculating the area. So this is how you can create your rectangle. And then ls functions, we have seen ls function is going to display, is going to give you the list of all the objects that you have created so far. So these are all the objects that I've created so far in my environment. All these objects we have created. And then if you want to remove any of the objects, you are free to remove them. You can simply keep on adding any of the objects if you want to remove. lemon underscore price. I want to remove. So you see, it is giving me some warning message. What is the warning message it is giving me? Because I have already removed my height and weight, it is saying I was not able to find out these objects. So it was only able to recognize this variable lemon underscore price, and it was successfully able to remove those variables from your environment. So that is what it was able to do. Now, and basic data types we have discussed. What do you mean by numeric data? What do you mean by character data? What do you mean by logical data? We are able to find out. And we have created this kind of data. So we can create our own data. And then it is possible for us to do some data analysis on the data what we have created. So we have seen how to create our numeric data, how to create our character data, how to create our logical data. We have seen this. And also how to convert your data types. So if you want to convert your data into character, you can use as.character. If you want to convert your data into numeric, you can use as.numeric data. If you want to convert into logical, you can use as.logical. So like this, you can use for conversion of your data into different data types. So this is what we are supposed to understand here. Then for checking what is a particular data type for your object, you can use this.numeric functions. You can use this.character functions. You can use this.logical functions. And then you can also use class function for finding out what is the data type for your object that you have created. And then we have seen all these functions today. And then we have discussed the concept of your vectors. So we have created our numeric vectors. So we have created our character vectors. We have created our logical vectors. And then we have also used some functions such as names function on top of these vectors. We have used our cbind function for combining our vectors into columns. We have used row names function for changing our row names. And then we have also used another function for checking for null values, is.na, for checking for your null values. And then we have discussed that it is possible for us to perform imputation on your null values. That means you can modify your null values. You can replace those null values with an alternate suitable value for us. And then you can clean your data. Fill your missing value data. This is what is data frames or matrices. we'll be working, we'll be doing some operations on the data, and we try to extract information from our data. So that is our job. So trying to understand the different structures of your data, and then trying to apply our functions and trying to extract data from your data frames, your matrices, your vectors, all these things we are going to see going forward. And then also what we have to discuss is different types of visualizations. Okay, how to create different types of charts and how to explore our data. So that also we'll be discussing going forward in our sessions. So far, try to revise whatever concepts we have discussed in today's session. In yesterday's session, we have applied some statistical functions, mean, median, mode, variance, standard deviation, all these things, attach functions, detach functions. So all of them are going to help you understand how to import our data set in RStudio, how to import our data set in RStudio Cloud, and do our basic calculations like summary functions, head functions, tail functions, subsetting our rows. So all these things we have seen. So we'll continue discussing in the same manner going forward, and then we'll try to understand some more topics. So this was good exercise, good practice, what we have done today, trying to understand some basic concepts in R program. So with that, let us break for the day here. And then again, let us continue in our discussion, in our journey in learning R programming language. Again, from tomorrow onwards. Till then, take care. Thanks for your time. Stay safe and bye.